Lesson 6.2 is Introductions into Sine and Cos Curves. Now, normally this lesson takes a full period in class, a full 75 minutes. I'm just going to give you the bare basics on how you come up with a sine curve and a cos curve. In order to save time, I've already gone ahead and typed these angles into my calculator and written down these decimals. So, for example, I just did like the sine of 135. Got 0.707, I rounded to 0.71. I did that as I went from 0 all the way to 360. So these decimals I get just from putting them into my calculator. So what essentially we're doing here is we're graphing our circle. So as we go from 0 degrees all the way around 360, I'm getting these decimal points and I'm going to go ahead and graph those. So what we're doing is back to Unit 5, 5.3, 5.4 lessons, where we have our unit circle. And if you remember, we did the sine, cos, and tan of 0, 90, 180, and 270. And we determined that sine is equal to y over r. And the radius of our unit circle and our y value, as we go from our point on that circle down to our x-axis. So we're taking that y value of our triangle and dividing it by the radius of our circle. And we get kind of these decimal points. So I'll go ahead and graph those. So at 0 degrees, we're clearly at 0. At 30, we're at 0.5. 45 is at 0.71, so kind of up around here. At 60, we're at 0.87. So 0.87 is about here. At 90 degrees, we're at 1. At 120, we're back to 0.87, then 0.71. At 150, we're at 0.5. At 180, we're at 0. At 210, we're down to negative 0.5, negative 0.71, negative 0.87. At 270, we're at negative 1. Then negative 0.87, negative 0.71 at 330, negative 0.5, and then at 360, we're back to 0. And then if we connect those points as we go from 0 to 90, 180, 270, and then back up to 360. And that creates what's referred to as a sine curve, because we're graphing the sine of those angles from 0 to 360. So as we go around our circle and we get our decimal for those angles and we graph them, this is the graph that we get. Now what's interesting to note is that once we get below 180, or our angles greater than 180, we get below the x-axis because all of our decimals are negative. Now if we think back to the cast rule, right, C-A-S-T, we talked about how sine is negative once you get down into quadrants 3 and 4. And the same thing happens when we graph our angles. We end up with these negative decimals, which creates this little section here, down here between 180 and 360. Those are the negative values for quadrants 3 and 4. For quadrants 1 and 2, between 0 and 90 is quadrant 1, 90 and 180 is quadrant 2. We're obviously above the x-axis to create those positives. So what we're doing is we're going from our unit circle, starting at 0, and working our way around until we get back to 360, and we're graphing those angles. And when we graph our circle, as we go around 360, it creates this type of graph. It's referred to as a sine curve. Now, anytime you want to graph a sine curve, you don't necessarily have to include all of these decimals. There's really only 5 points that we really need to worry about. 0, 0, 90 at 1, 180 at 0, 270 is negative 1, and 360 is at 0. So in order to graph a sine curve, what you would do is to do a quick sketch. You put a dot at 0, 0, then a dot at 360, because that's the period of a sine curve. 360 degrees, one trip around a circle. You put a dot at 180. Then between 0 and 180, we find the middle, which is 90. That you put a dot at 1. Then between 180 and 360, which is at 270, you put a dot at -1. So first dot, second dot, third dot, fourth dot, fifth dot, and that gives us our sine curve, those 5 points at 90, 180, 270, and 360. Now we also have a cos curve. Now cos, again, I just typed these into my calculator to get the decimal. Cos is equal to x over r. So sine, I took the y value divided by the radius. Now I'm taking my x value divided by the radius of my circle. And that gives me these decimals. So if I want to plot these points, now at 0 degrees, I'm at 1. Then at 0.87, 0.71. At 60 degrees, which is here, I'm at 0.5. Negative 0.5, or sorry, at 90, I'm at 0. Then negative 0.5, 0.71, negative 0.87. 180, I'm at -1. Then I work my way back up to 270, where I'm at 0. And then I finish at 360 and 1. And if I graph these points, I cross at 90, I cross again at 270, and I finish at 360. So slightly different than the sine curve, I create a cos curve. And again, where's cos negative? Between 90 and 270, right? Quadrants 2 and 3, where cos is negative. Positive in quadrant 1 and in quadrant 4. So I start at 1, down to -1 at 180, and then back up to +1 at 360. So again, in this case, there's really only 5 points that we need to worry about when we sketch this. We start at 1, and we end at 1. In the middle at 180, we're down here at -1. We cross at 90, and we cross at 270. So we end up with this. And that essentially is where we get the sine and cos curves from. We're not doing a tan curve. That's for grade 12. Grade 11, we only focus on sine and cos. So we get these graphs by essentially graphing the circle. As we go around the circle from 0 to 360, we take those angles and we graph them. And the reason why cos and sine are different is because cos is the x value divided by the radius, whereas sine is the y value divided by the radius. So similar, but yet different. And the reason why you need to know these is because in the next lesson, we're going to start graphing transformations of sine curves and cos curves. So for this lesson, really, the only thing that is essential is you know how to graph a sine curve using those 5 points and how to graph a cos curve using those 5 points. And for this lesson, there is no homework. We're going to get to that when we get on to the next lesson, which is graphing the transformations of these.